Dun dun dun. What do we have here? Like a whole bunch of transmission parts all over the place. Are these gonna ever work again? Hi Beauty, where's Rusty? Hi Rusty. Meet Rusty and Beauty. Rusty Beauties. So yeah, welcome to the Rusty Beauty's garage and the 1975 TR6 by the name of Orange Pillar. And that's how it's spelled for real, no E. We have to do many jobs on this car, but the first one that we started was the transmission, so we took it apart because the owner said that he blew the Synchro on the second gear. And it turns out, yeah, the Synchro is worn, but the bigger problem was that one of the spacer washers, whatever it is called, was broken. And that also damaged the top hat bushing, which is now garbage. So all this here is his transmission that came out of the car. All the parts, the overdrive, the housing down there, and the cover. And this is the top hat bushing, and this surface here is what is really damaged because the washer, I don't know now where the other part, the leftover part of it is, but I kept it. So when this washer broke, it just ground the edge of this bushing. Also, the second gear, you can see it got overheated a little bit and it changed color here on the cones. Also, the shaft here is a little bit, you can tell it's been overheated. So we'll see what we're gonna do, but obviously we need a new top hat bushing and a new washer, the one that was broken. So for this reason, Dave brought his old transmission, non-overdrive, the one that he took out of the car to replace with the overdrive transmission. So he said I could use it for parts, so I did. I took it apart off camera and I took out the parts that I needed, and I think, even though it's a little bit different, I think we're gonna make it work. So without further ado, let me put this stuff away that we don't need and let's get crack-a-lacking. Okay, so I arranged here on the table all the old parts that came out from the transmission, and just to mention that in the previous video we inspected visually everything. The shafts, whether they have wear, the thrust washers and everything, but now we're gonna have to inspect a little bit more scientifically the parts, end place and stuff like that. So first of all, let me show you how everything gets assembled so we can have an idea what we are doing here, what we are measuring. This is our counter shaft that goes under the main shaft with the two thrust washers on each side, and this is our reverse gear. So we're gonna leave this alone for now. We're gonna focus on the main shaft and the input. And the main shaft is divided in two by these splines here. This is where this hub goes on these splines, and then these parts come from this side and these parts come from this side. So this is first gear and this is our second and third gear. They come on this side. So first, this washer, this is the broken washer. This is supposed to go on the main shaft right here. And then after it, we have the second gear with the top hat bushing going in this direction. Now, unfortunately, our top hat bushing, we had to press it out on the press. I don't know what happened, but it's not going on the shaft, so I'm just gonna eliminate it, but you have to know that it pushes all the way there and keeps the gear centered. This also stays here, right? This is our damaged part of the whole assembly. So then, since the bushing is inside, this is gonna act as a washer here on the outside. And then we have our third gear with its bushing inside that goes here. And then we have this, okay, the bearing doesn't need to be there yet. We have this dished washer, and then we have the circlip that locks them in place. and that's one side of the shaft. Then we have the hub with the two synchro rings on each side. Inside we have the hub that goes back and forth. This is still missing some springs and washer and bolts. We're gonna take care of them later. That goes on these splines. And then we have the bearing and the input shaft. So this is one side. The other side is, again, first the hub. I don't remember if it was this way or this way. Doesn't really matter right now. I'm just gonna put it like that with the two synchro rings, right? And then we start with this. We have adjuster washer. These come in different thicknesses to adjust the end play. Then we have the first gear. Again, it has bushing inside. Then we have this, again, adjuster washer, and then the bearing, which needs to be pressed into this space here. And after the bearing, we have this last washer that ends up right there, and then we have a circlip. So that's how everything goes together. But we need to make sure that each and every bushing is still good for the gear. So if we take out the first gear, for example, with its bushing, you see how it is trapped between two washers. And all of the gears are like that. They have a bushing inside and two washers on the outside. Just second gear doesn't have a washer on one side because the bushing has the washer attached to it. But the other gears, the first and third, I'm not talking about fourth because fourth is direct, it doesn't have its own gear, so we have only first, second and third. So first and third have washers on each side. And these washers, together with the bushing, create a space, let's take it out, like that, for the gear to ride without being compressed between the two washers. So the bushing is just a smidge wider than the gear, which allows it to spin freely without being compressed, but it doesn't have too much end play here. So if you put the two washers here and you compress them hard, the gear should still be able to spin without dragging. So it's important that this bushing has certain protrusion. So that's for first gear. And for third gear, we have this washer on one side, and on the other side is the top hat bushing. That's for second gear, but it's the same thing basically. This bushing should protrude here, just, I have to find out the spec, but just 2 or 3 thou, I believe it is, so it doesn't trap the gear inside. And here it feels like it is trapped, but we will see. And for second gear, it is again the washer on top hat bushing on one side and this washer on the other. So now here we know for a fact that this doesn't protrude anymore because the broken edges of this washer literally ground the edge of this bushing. So now we know that this bushing doesn't have any protrusion anymore. So we have to figure out how to fix the problem with this whole assembly here. So before I took the second transmission apart to use parts from there, I went in my parts and I found a top hat bushing that I had brand new, a steel one. But if you notice here, it is a little bit smaller. And that's because this is for later transmissions, I believe. There are some differences between early and late transmissions, and this is one of them. So my top hat bushing won't work for this transmission. So that's why I decided to take apart the other transmission and see if that one has the same top hat bushing and washer here. So I took apart the other transmission and we have also a steel bushing there, a small one. So it is different. But the difference is not only the diameter of this part here, it's also different width here. So if we take out this bushing, for example, and we compare them, you can see that even though this is worn here, still this bushing is way narrower. If you compare them this way, this one is taller, this one is shorter. So unfortunately we can't just swap the bushings. But the top hat bushing fits perfectly here, no problem. Actually it goes this way, right? The problem is that if we put it here, and the problem is that if we put it here, it's not going to be tall enough, and it's going to compress the gear again because the gear is wider. And we can show you that. You can see here also, if we put it inside the gear, it doesn't protrude at all. So if we put the broken washer, we put it here, it's going to be compressed. But if we take the other second gear from the other transmission that came with this bushing, here it protrudes just fine. But this means that this gear is narrower, right? Because the bushing is narrower and it fits well here. This means that also the gear is narrower, and that's gonna give us problems. But the difference is not in the height of the gear, it is actually in the depth of this channel here. This one, the one that came with the narrower bushing, is narrower inside here. So from this face to this face is narrower, but from this face to this face it is the same as from this face to this face. It's just inside here, this is deeper than this, you see? And to compensate for this, they just put a thicker washer. So this is the one that is broken on our transmission, and I'll show you the difference between the thickness of this one and the broken one. The broken one is much narrower, and they used much wider one with this other gear. So can we take this whole assembly and replace this assembly? Yes, I think so, as long as our teeth match. But I think our teeth match perfectly here. You see, everything is matching just fine. So the only difference is the width inside, and I don't know why they changed that, but we're perfectly fine to replace this assembly with this assembly. So let's do that. Pam, pam, done. And it matches perfectly here. No problem. So this problem, I think, is solved, and now we're ready to assemble as long as our end plates are good. We can double check that visually, then we're gonna measure the end plates, but let's check that visually. So now this is where the broken washer was, the narrower one. Now we're gonna put a wider one, and then the second gear with the top hat bushing, then the third gear with its bushing as well, and then this washer, and we end up just at the channel here for the circlip. So visually it's perfect, but we're gonna measure it with the filler gauges to make sure. We don't wanna just do things visually, right? Okay, so now we have to measure the protrusion of each of these three bushings. So let me find how much they need to protrude, and then we're gonna measure them. Okay, so the protrusion needs to be between 4 and 8 thou. This means that the bushing needs to be 4 to 8 thou wider than the actual gear. So let's start with First of all, we want to make sure that everything is nice and clean. There's no any debris inside, because everything matters, right? I'm gonna go like this, and we're gonna take, this is the washer that goes on this side, but we're still a little bit too deep here. We want to build this up a little bit taller, so we're gonna take temporarily this washer from here, and we're gonna put it like that, and now we are above this face here. So now we can take everything and flip it upside down, and now here we can measure the protrusion. And I'm gonna use a 123 block, which is a machinist precision tool. And now we can see here, this is 4 thou leaf filler gauge, and you can see that it goes easily underneath, which is good. Let's see how thick it is. This is 5 thou, and 5 thou is dragging, so it is 4, but it's still good. You know what, let me check, just for the hell of it, we're gonna check this one as well. They are the same, I mean, they are interchangeable, that's what I mean. Yeah, 5 is fitting here still, 6 is dragging, so let's call this 5. But let's see now this one, let's see what's gonna happen here. So we're gonna do the same thing with this bushing. Let's take this to the side. This should work the same way here. No, 6 doesn't fit. 5 doesn't fit. Where did my 4 go? Even 4 doesn't fit here. Wow. Okay. Let's then check with this bushing again. So that bushing might be a little bit too far gone. Yeah, 4 fits well. 5 fits just enough. So the same story, exactly the same story. So let's put this one here. We know that this one is 5 and it's good, but we need to do something about this one. Let's measure this one again with this bushing. We've never done that. So 4 fits here, so we can use it in the worst case scenario. But you know what, I'm gonna bring the steel ones from the other transmission. So we know that this one is 4 in this application, and this one is 4. Like, it is pretty tight here. Huh. Let's check this one. I want it to be 5 at least. I know it is 4 to 8, the tolerance. Wow, this one is even shorter. Yeah, this one is not good. So what should we do? So you know what, let's use this one, because we know that it is 4 and it came with this gear. Okay, so this one is 4, this one is 5. Now we have to check second gear though, and that's a little bit trickier, because we can kind of do the same thing with these washers here, right? But like that, just to make sure that they're thick enough. Oh, they're not thick enough because this one is deeper. Haha. So we need something else. Let's take this one. Okay, now they're deep enough. Now the problem is that here we have this step and it's not easy to measure. So what you can do is you can actually take a micrometer and then you measure the thickness of the gear and see the difference. But I think it is overkill. you can actually measure it like this, and that's like you can see that the gear spins. Doesn't matter how much I compress it. The gear, like I can put my weight on it and still spins, right? If it was too narrow, it wasn't gonna spin. But yeah, I think that's 4. Yeah, 5 won't go. But 4 fits well. Okay, we're gonna consider this 4. So we have 4, 4, and 5. That's great. But that's for each individual bushing. Now we have to check the end play on the shaft. So for that, what we can do is take only the bushings without the gears. We can put this one here, take this one out of here and put it without the gear, put it like this, then the one from the 3rd gear, put it here, then this washer, the dished washer, not the dishwasher, the dished washer, and then we can put here the circlip. But I don't want to put this one because that's going to give me lots of trouble taking it out. But I have some half ones. I have a broken one that I can put there just to lock it in place. And once it's locked in place, we need to have here between 3 and 9 thou end play. So all the bushings should be able to play left and right by 3 to 9 thou. Alright, so here's my broken one. It's an old discarded one, but it is the same as this one. So I can put it inside, but if you don't have a broken one and you only have one, then what you can do is you can take this dished washer out. And some transmissions actually, this is not even a dish, it's a flat washer, but if you have the dished one, you can flip it around. And again, it's going to be the same thickness, right? Just the flange is going to go this way and it's going over the bushing, so it doesn't really matter. And then you can take the back of your circlip and put it like that, and then you can measure your end float here. It's trickier, but it is something that you can do if you don't have another possibility. Now we have another possibility, so we're just gonna put this inside there. It's still tricky, still not very easy to put them in and out. But now we can measure the end play here. So here we need to have 3 to 9 thou of end play. So this is 5. This is actually pretty wide. 5 doesn't fit at all. And 4 doesn't fit. 3 thou fits just fine. But so we are within tolerance. But if we need to adjust this, we adjust it with the thickness of this washer. There are different thicknesses available, so you can't correct the bushing because that's going to change your protrusion, right? So, okay, let's see now how we're going to take this out. I'm gonna deal with that later. Now let's do the same for this side. So here we know that we have this washer first, and again, this is the one that comes in different thicknesses. That's the one that adjusts this side. And here we only have one bushing. Then we have this washer. Now we have the bearing, which needs to be pressed. And you know what? I'm gonna press it in. I'm just gonna put this here like this. Shouldn't take too much force, right? Or should I flip them around? Okay. We don't want to overdo it, right? As soon as this washer stops spinning, we're gonna stop. There you go, it stopped spinning. Now the washer and the circlip just fits there. Make sure the circlip is in its groove, which it is. But now the bearing is compressed and the bearing is pressed all the way here, so there for sure there's not going to be end play. So now we have to push the bearing back this way and get rid of the lash here. So very, very gently we're gonna go this way now. Just very gently, right? And now we should have this end play here, so let's go measure it. Now this washer won't spin, which is good. Now this end play should be between 3 and 9 tau as well, and I have the feeling it's 3 as well. Yeah, 3 fits just like a charm there. Let's try 4. No, 4 won't fit, but 3 is like perfect. Okay, so now we have to remove everything, press the bearing out, but this is basically the base where all the gears ride, right? That's our first, the hub, second, third, the other hub, right? So now let's take them apart, and we just need to take care of the hubs, and from there we're gonna be ready to start assembling. All right, so everything is taken apart again. The washers went when they belong, the bushings went where they belong. So now the only thing is the hubs and the synchro rings. We're gonna take care of the synchro rings next. So let's first assemble this hub, because we know that this hub is, it fell apart as we were taking it out, right? So let's get rid of the synchro rings for now. I have 3 bows again. One was missing when we took the transmission apart. I don't know if we lost it or it was missing before that. It's quite possible that we lost it, but anyway, the hub is this. This is the hub, and the selector ring moves this way or this way and connects these splines here, or teeth, with these teeth here. And now this becomes one unit. When it slides backwards, now we have a spring sticking out here. Now this becomes disconnected, and if it is in the center, it's still, this is disconnected, but if it slides more, now the center and this one are connected, this one is not. So that's what the selector ring does. So to keep this ring from sliding on its own back and forth, there's these 3 springs inside these 3 holes, and the springs are still there. So we put the bows inside, let's see, and now we can put the ring back on, and now we have to press hard in order the bows to go in. There you go, you see how the bow goes in? Like that. There you go. And now this won't come out on its own, but if you push harder, see how it clicks. So there's measurement here, how much force it's required to move the hub in one direction or another, but we're not gonna go that deep. I just go by feel here, and this feels good. Now the only question here is, the ring doesn't have a direction, it's symmetrical, but the hub itself has direction, because this boss here is shallower and this one is deeper or higher. And how I remember it is the higher boss is towards the higher gear and the lower boss is towards the lower gear. So here, this one is between third and fourth. Now, so the higher is towards fourth. So if we connect this to this, then we're in fourth gear, right? So this is how this hub goes, like this. And this one, that goes right in between here, right, on these splines. Let's take out the synchros as well. This one we never took apart. So they're bows, and I'm just gonna make sure that the bows are still there. Now they're not. So we have 3 of them. Okay, so they're all there. And this one doesn't really have a direction, I think. The hub doesn't have direction. The bosses on both sides are the same, but this channel where the fork, the selector fork goes, needs to be forward towards second gear. First gear is where these are the teeth for the reverse. So this is how this one fits. Okay, so I'm gonna put it like that, and I'm gonna put this like that. And now the only thing is the synchro rings, and how you check whether they're worn or not is by putting them on the taper here, and you measure this gap. You can push them in by turning them a little bit gently. It needs to be minimum 30 thou. So here I have 20 and 21, let's say. That's 40 thou. And I actually have pretty good end play here, everywhere. Pretty good, like, that's exactly 41 actually. It's probably even more than 41, but that's actually a good synchro ring. Let's take this one. They're all the same. So this one is a little bit tighter, but still fits 41 thou. Maybe a little bit less. This one is tight. So this one is less than 41. I'm not gonna measure it exactly, but it's probably 30 thou. So this one is almost gone. And this one is also loose. So there's 3 of them that are not bad. One of them is only bad, probably that was the second one. But they've bought these custom steel rings and they have this material inside. So the old ones, there's like little channels here, and when they get worn, this diameter becomes wider and wider, and they fit closer and closer to the gear until they are not able to stop it anymore. So this is the new one, and it has this material inside. Like, I'm assuming this is like a clutch material or like a brake pad material. So I don't know, I never used these before. They've got them, they're quite pricey. I think they are like 80 US for one, but they act like a clutch. As the hub pushes it towards the gear, it locks it into the gear and then synchronizes the speed of the hub and the gear, right? That's why they're called synchro rings. I have an entire video on how synchro rings work. So we can put one synchro ring on each side of each hub, and then we're going to be ready to assemble. So now I'm going to clean everything thoroughly and we can start assembling. But that's gonna happen in the next video, otherwise we're gonna have an hour-and-a-half long video, and that's a little bit too long for my channel, so we're gonna end this one here. Thank you guys so much for watching, commenting, subscribing, sharing and supporting this channel. Stay tuned for more on this transmission and the good parts upgrades on this car that are gonna be done in the next few episodes. Thanks again, and I'll see you in the next one. Bye!